Alright, so you're studying chemistry. What's the worst that can happen? Well, in most classes, the worst that can happen is just abject total failure. Just like failing a test, failing the class, having to rethink your life choices, maybe even quit, drop out of school, get a job public gas for the rest of your life. But in chemistry, the worst thing that can happen is death. And I don't want to make light of this, labs are dangerous places. Chemists die younger than the average person, both because of workplace accidents and cancer caused by exposure to chemicals. But chemists have also done more to increase the average lifespan of humans on Earth, in my opinion, than any other profession, so it's unnecessary. So it's probably important that we talk about acids and bases, as they are the substances that make our world the world we know and love. Some of them are benign and beautiful, some of them are face-meltingly terrifying, quite literally. Well, first, what exactly are acids and bases? Acids are, well, sour. That's the first thing we learned about acids, actually. And acids actually mean sour in Latin. They're also excellent at dissolving things and killing things and melting your face off. You might have some idea what a base is. It's bitter tasting, slippery like soap. Soap is in fact a base, and bases, like acids, are totally dangerous and can melt your face off. They're also like the anti-acid, basically. In fact, during anti-acids, if you mix acids and bases together, they neutralize each other. Like most things in chemistry and in life, when it comes right down to trying to define exactly what something is, it gets weird, and messy, and confusing, and terrible. The most common acid is water. What? And water is also the most common base, and am I saying this purely to confuse you? Well, yes. Well, mostly to convince you that the world is way more complicated than you thought it was. In 1923, two guys simultaneously defined acids and bases in the exact same way. Bronsted and Lowry defined them. They did not classify them by how they acted, or what they tasted like, or even what they were made of. They defined them. And this was an impressive feat because a huge class of molecules, to some extent or another, act as acids and bases. So to come up with a definition that fit all of them, that was not so simple. Bronsted and Lowry defined an acid as being anything that donated a proton, and a base is anything that accepts a proton. And when we say proton, we're talking about a hydrogen atom without its electron. So when an acid is added to water, it dissociates like any other ionic compound, forming H3O+ and the negative ion. The acid has donated a proton to the water. So let's take a look at the dissociation of hydrochloric acid for some more terminology bits here. You see right off the bat that the HCl is donating a proton, but with many acids, particularly weaker acids, the reaction can actually go back the other way. So in this situation, every chemical in the reaction, also sometimes called the major species, can be called an acid or a base. On the left hand side, the water is accepting the proton, so it's the base, and the HCl is donating it, therefore it's the acid. But on the right hand side, the Cl- would be accepting the proton, so therefore it'd be the conjugate base, and the hydronium ion is the conjugate acid. For every acid there is a conjugate base, and for every base there is a conjugate acid. A previous definition of acids and bases, particularly the one proposed by our old friend Arrhenius, relied on a specific major species, most notably our friend the OH or hydroxide ion. While hydroxide is in most bases, it is not in all of them. For example, ammonia acts as a base when it reacts with hydrochloric acid to form ammonium chloride. There's no hydroxide, but there's definitely proton donation and acceptance going on. The reason why the most interesting acid-base chemistry happens in water is that dihydrogen oxide is really great at either being a base accepting a proton from an acid, or an acid donating a proton to a base. Thus, water is the world's most common acid and the most common base.